everybody, and welcome to this tutorial. Today I'm going to do a follow-up on my previous one, and I will actually decrypt a file. I will decrypt a file that I have captured in monitor mode, and the traffic which is not my own, in terms that it is not from my own computer. Rather, instead it is from other computers that are on the same network. And to do so, I will of course first need to open up the file in WIRESHARK, and as I have mentioned previously, I will not open the file which I have captured. Rather, instead I will open up a sample file from the internet in order to perform this decryption. I cannot decrypt my own file, obviously, for safety and security reasons. So with that out of the way, I'm just going to go ahead and navigate to a folder where my sample file is. Let's just go cd to tmp. When you're downloading things from the net, you should generally store them in the TMP folder and not give them any permissions, especially if you don't trust the source. I do trust the source, but still, it is good practice anyway. We'll just go ahead and see what is located in the temporary folder. And I have, yep, it's the last one. You see VPA induction PCAP. So I'm just going to go ahead and type in WIRESHARK, and you can actually, as I've said before, you can pass an argument to WIRESHARK, and that argument can be a file, and it will open up that file. So let's just go ahead and type VP. Oh, nope, that's VLP. So VP, press tab, and it will auto-complete the rest of the name. Press enter, and WIRESHARK will now open this file. It is in an encrypted format, and as before, you won't be able to see or recognize pretty much anything. You will be able to recognize some of the protocols and stuff like that, but other than that, you will not actually be able to see what the information contained within is. For example, if I click on this, nope, that's not the one that we're looking, because it doesn't really contain anything. There's nothing really encrypted in it. We need something with information. So I'll just go ahead and scroll down. You also need to go past the authentication, so just go deep down, and there we go, AppleTalk data, and as before, you can see that it is completely encrypted. You cannot make heads or tails out of this. This is completely useless information to you. In order for us to be able to decrypt this, we need to provide WIRESHARK with decryption keys. So the first thing that we need to do is go over to edit. We have learned how to what each of these options does for you, what you can use it for, where is what in the previous tutorials where we dealt with WIRESHARK interface. So go ahead and click on preferences. We've been here before, so nothing new, shouldn't be too difficult. Just click on it, it will open up, and here you have a bunch of options that we went over. We're going to go ahead and click on protocols, and there are a lot of them. So don't just go scrolling down to it, rather instead just click on one, any, doesn't really matter, just pick a random one, click on it, and then start typing capital I and triple E. And there we go. We are at IEEE 802.11. That is a wireless standard pretty much that is universal in the world. Here, we need to do following things, and please pay attention because this is quite important. It says here, enable decryption. It is very important that you toggle this, that you click on it, because it is not marked by default. And even if you pass your decryption keys and everything and apply it and say okay, nothing will actually happen. WIRESHARK will simply store the decryption keys, but it will do nothing with them. I mean, absolutely nothing. So you do need to enable decryption first, and then head over to decryption keys, click on edit, new, as you need to create a new decryption key. That is very important. And I don't know, for some strange reason it pops in the upper right corner. I have no idea why that is happening. So you have a key type here. You have a WEP, you have VPA, PWD, and you have VPA PSK. So WEP is a very old style of wireless encryption. It's in short, it's wired equal protection, something like that. I'm not too sure about that, but doesn't really matter. Nobody uses this anymore. All the people who are using WEP today, I mean, there are very few of them. Maybe out of about 100,000 people, one person is still using it for some strange reason that nobody knows why. But in general, you won't find anybody using it. Down below is what you need. It's VPA-PWD, so a password key. And this is a personal key, which is also used, but for the time being, we need this one. So depending on what sort of encryption it is, what sort of a traffic you have captured, take a pick from these two. So from these three. For wireless, it can be these three, and that's it. You just need to figure out which one have you captured, and usually, I mean, 99% of the cases you will know this prior to the capture itself, because as soon as you click in your network manager icon, and when you want to connect to any of the wireless access points around you, it will basically tell you this one has VPA, this one has VPA2, this one has WEP, and so on and so forth. So this is the one that you need now. And for key, I'm just going to go ahead and paste the key here that I have taken from elsewhere. And in this key, there are several things which you need to pay attention to. So the first thing here, you don't need this. I've just copied it like that. But that is basically stated here already above where it says WPA-PWD. So the first one, the first portion of this before the semicolon that I've marked, that's the wireless password. So that is the password for the wireless which you wish to decrypt. Then you type in colon, and after colon, you need to type the name of the wireless network. The name of the wireless network can be anything, just like a password. It is public, anybody can see it, so you can name it whatever you want. It doesn't really matter. What is important, however, is that you will need that name in order to perform the decryption process successfully. If you do not pass the name argument, WireShark will try to decrypt this with the last known name of a wireless, and more often than not, that will not work out to your advantage. Believe me. So you do need to pass this argument, even though it's not mandatory. You do need to pass it, because WireShark will only get confused and you will not get proper output. Press OK. Remember to click Apply and confirm with OK. You can see that the background has changed a bit. Press apply again just to be on the safe side. Nothing else really. I'm pretty sure it has already figured it out. And click OK. That is pretty much all that we need in order to decrypt these packets. Some of them will of course still be encrypted and you won't be able to read them, but if you scroll down to the bottom, the closer you get to the bottom of the packet, the more and more packets will be decrypted. So there we go. We now have HTTP traffic. There we go. We have a get method there. We can pretty much see what websites have been visited. There we go. Again, we have HTTP, more HTTP gets. There we go. We have a TCP segment somewhere along the way. You can see that somebody has apparently, yep, there it is. It's a JPEG that somebody has apparently downloaded or loaded into their browser. A JPEG from somewhere. You can figure it out from where by just going through these packets, going a bit backward and seeing which website has been visited and following through the link and following up on the link on the connection and so on and so forth. But now you can see that the information contained, let me just see if I can do this, if I can aim it perfectly. Yep, there we go. Now I'm just going to minimize this, and there we go. Now we have all this information in decrypted format, and the last one is what we want to know. That's data. You see that the hypertext transfer protocol is no longer encrypted. You can see everything that is going on here. All the information is there for the taking, from the user agent to the browser. User agent is Mozilla, Macintosh. You can see what it has accepted, an image, and in other packets you can see also from where, and so on and so forth. So in this manner, you can decrypt these packets and you can figure out what is going on. You can monitor your own network or the network that you have a permission on to monitor, and you can pretty much see all the traffic going on. As long as you have the decryption keys, all traffic going over that network will be perfectly visible to you and nobody can hide it there from your site. especially need for small offices or something like that, where you need to quickly figure out what is going on or something of a kind. In any case, this concludes this mini series within the course in regard to the monitor mode. I hope that you've enjoyed it, and I hope to see you in the next one.